What's up, Accelerated Algebra 2? Stirrup here. Hey, just want to let you know this is the notes for 4C. These go along with your packet, so make sure you take a look at that packet, fill it out where you need to, and any questions you might have, make sure you ask them in class. We're going to look at absolute values, but before we start in absolute values, I know you've probably seen how they're graphed, and I agree with you. But we're going to use something called a piecewise function to deal with it. Okay, so we're going to use some terminology you've probably never heard before. It graphs the exact same way, but this, I assure you, by learning it this way, can help you in pre-calculus and calculus if you choose to do that. So the first thing I want to do is I want to find something called the critical value. Critical value. Okay, and you're like, what? And I'll start referring to that as CV. Okay, so what I'm going to do is I will take whatever is over here, and I will set that equal to 0. Agree? So that means at x equals 0, which is right here, that's really not part of my graph, but I'm just drawing that in right now. You don't have to draw it, but that's what's going to take place. That's where our directions are going to change. So we'll keep that there for a moment. And then what we're going to do is we're actually going to break this into 2 problems. So we're looking at this right here, and I'm going to break it into 2 problems. So I have f at x, and I'm going to get rid of the absolute value sign, is equal to x, but then I also have f at x equal to negative x. Okay? So let's go ahead and graph the blue one first. So I would have a value here, up 1, right 1, up 1, right 1, and then down 1, left 1. So technically this graph, just this whole thing would look like that. And you're like, wait a minute, it's absolute value. It should look like the letter B. You're absolutely right. And I'm drawing the whole linear equation that goes with the blue right now. Now I'm going to go ahead and do the green. So again, the green goes here, and I go right 1, down 1, left 1, down 1. So this continues this way forever, but then it also continues this way forever. And I know that's something that you have not done that way. This problem is not done at this point. What we have to realize is there's a portion of this problem that we're going to ignore. So I'm actually going to highlight only portions of this problem that are important for us. This and this. That's our problem. That's what our graph would look like, the yellow highlighter. Okay? But then other things that go with this is we have to kind of think about, let's set our domain. Okay? Our domain for just this goes from 0, square bracket, to infinity. So it starts here, where I'm circling it, and it's going to continue this way forever. But the f at the negative x is going to come from negative infinity and go to 0. Now I'm going to have one of them with a square bracket, one with a rounded bracket. The reason I do that is because we're not going to count the point twice. It doesn't matter if this bracket is square and this one is round, or we can make it flip-flop. You just have to pick one of them that goes with. Okay? So our graph itself just looks like what's above. The main thing is finding that critical value. Let's explore to see what it does a little bit further. Okay? Here's our general equation. This does all kinds of things to it. Notice this b is being brought out front because you want this to always be a 1x, and we'll talk about that a little bit later with these. Well, let's go ahead and take a look at the next question. Okay, again, we want to make it as a piecewise function. And I'm not going to draw the entire graph this time. First thing I'm going to do is I'm going to find the critical value. So I'm going to do this. I'm going to go negative x plus 6 equals 0. So negative x equals negative 6. So x is equal to positive 6. Okay? I take that back. We're not going to look at it. We're only looking at this portion equal to 0. The other part shifted up and down. So I made an error here, here, and here. So I'm just going to go negative x equals 0. Whatever is in the absolute value, so it's equal to 0. So that's my critical value. So that means this right here is where my turning point is going to take place. And again, we don't really have to put that line. I'm just putting it right now so we can see it. So now we're going to go ahead and work this problem. So we have 2 different portions to it. I'll do one in blue. So I have negative x plus 6, and I'll set that equal to 0. And then I have negative x plus 6 equals 0. So the first one, if I solve it, I get negative x is equal to negative 6. So x is equal to 6. I don't know what I'm doing anymore. My friends, I've recorded too many videos. I just wanted to break them apart. I'm sorry. Okay, in red, I'm going to have negative x plus 6. That's one of my equations I'm going to graph. My other equation I'm going to graph is going to be negative x plus 6, which means x plus 6. So I'm going to graph that as well. Okay, we're going to take care of the critical value. That's where our turning point will take place. So our red equation, we have a y-intercept of 6. So 1, 2, 3, 4, 5, 6. So I have this point here, and then I go down 1, right 1. So this is what this is going to look like. And then my black equation, again, I'm at 6, positive 6, so it's up there. I guess we could make it an open dot to make you feel better that we don't count that twice. And then my slope is going to be up 1, right 1. So up 1, right 1's great, but actually I'm going to go down and left. Down and left is negative. So this is what my absolute value graph looks like. So it flips upside down because of the negative up front. We have a critical value that's taking place at x equals 0, and then we solve it from there. Okay? Let's see if I can actually teach this more appropriately on this next problem. Okay, first thing I want to do, I want to find my critical value. Okay, so I'm going to take this right here, set it equal to 0, so x equals 5. At 5, 1, 2, 3, 4, 5, I'm going to have where my critical value is going to take place, meaning my turning point of my absolute value graph. We're creating this as a piecewise function. I'll do the first one in blue. So I'm going to go ahead and graph 2x minus 10. What I did is I just distributed over. Okay, so if I graph that, I have negative 10, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's down here. I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Put the dot there. Up 2, right 1, up 2, right 1. So there's the first part. So this part, the domain of this first part goes from 5 to infinity. I know I didn't do this on that class problem. Next problem I'm going to do in green. So what I'm going to do is I'm going to go y equals negative 2x. And all I'm doing is I'm distributing it over, and I'm going to change that value to a negative minus 10. Okay? So that minus 10 is still there, so that's down here. So what I would like to do is I'm going to go up to left 1, up to left 1. Oh, boy. I'm going to forget this part down here. So from this point, I'm going to go left 2, up 1, left 1, up 2, left 1, up 2. So this is doing this. So this domain is going to go from negative infinity to 5, rounding bracket. Okay? And third time's the charm will do much better. Okay, let's find our critical value where our turning point is taking place. Okay, so what we're going to do is we're going to say that 3 minus x is equal to 0. So negative x is negative 3. So x is equal to 3. So here's where my critical value lives. And then we're going to go ahead and graph it. So I'll do this first part in blue. So I'm going to get 3 minus x plus 5. Divide by terms, negative x. Negative x, is that plus 8? I have a y-intercept at 8. So 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go down 1, right 1, down 1, right 1, down 1. Got finding my critical value. Down 1, right 1. That's what my graph is going to look like. I'll do the next one in red. So I'm going to get 3 plus x plus 5. And that's going to give me x plus 8. So it's very similar. Do you see where your turning point is going to take place? So that's from there. I'm not going to go up 1, right 1. I'm going to go down 1, left 1. Remember, negative over negative is positive. So there's what this one looks like. So my blue domain goes from square bracket 3 to infinity. My domain for my red is going to go from negative infinity to 3. And again, I have one as a rounded bracket, one as a square bracket as 3's go. You pick which one you want to make that way. Okay, that's kind of extra stuff when you're doing these, but just so you know, it'll help you in your pre-calc. This was a little goofy because it's inequality. I mean, you have a greater than sign in this, so I have to shade a region. Okay, so I'm going to ignore the shaded region for now. Then I'm just going to go ahead and find my critical value real quick. So I have negative, or x minus 2 equals 0, so x equals 2. That's where my critical value is going to take place. So that takes place right along this line. Okay, and then from there, I'm going to go ahead and start graphing this. So I know I'm going to graph negative 1/2 x plus 1 plus 1. I've distributed the negative over those parentheses. That's kind of taking place. So I get negative 1/2 x plus 2. So think about this. Plus 2 is here. And I'm going to go down half, right 2. Put a dot there. And go down half, right 2. Down half, right 2. So that domain is going to go from square bracket 2 to infinity. Now I'm going to do the same thing. I bet you know exactly what's going to take place without even working more than proper. So I'm going to use that point right there. So I'm going to go down half, right 2. Down half, right 2. And that's what our graph looks like, where this has a domain from negative infinity to 2, rounded bracket. Your problem is all done. Okay, if you have any questions, of course, ask in class. Have a great day, everybody. Take care of one another. Bye-bye.